Question 9a, we got some nice differentiation. So a curve has equation y equals 2x add 3 over 4x squared add 7. And we want to find dy by dx. Thank you, Mr. Postman. So for this, we're going to be using the quotient rule. So another one that we need to remember, let's just go over here. If y is equal to u over v, dy by dx is equal to v u dash minus u v dash all over v squared. So here u is 2x plus 3, so u dash is 2 and v is 4x squared add 7, so v dash is 8x. So dy by dx then is equal to 4x squared add 7 times 2, so 2 lots 4x squared add 7 minus minus 8x times 2x plus 3. And then that's all over v squared, so that's all over 4x squared add 7 squared. So that is an expression for dy by dx. It doesn't say to simplify it or anything, so that would do. Part 2 then says, hence show that y is increasing when 4x squared add 12x minus 7 is less than 0. Now this is 4 marks, so a lot more fun than part 1, which was only 2. So first of all, let's think about what makes y an increasing function. So y is increasing when the gradient of y is positive. So when dy by dx is greater than 0. So again, part A, or part 1 of A, is going to help us with part 2. So we're leading on again. So we know dy by dx, that's what we just worked out. So now what we're going to do is we're going to substitute that into this inequality. So dy by dx was 2 lots, so 2 lots 4x squared add 7 minus 8x times something 2x plus 3 and then that's all over 4x squared add 7 squared. Now we're setting that greater than 0. So there's good news there. The first thing we can do to make life nicer is multiply the denominator on both sides, which is going to eliminate the fraction. So we're then going to get 2 lots of 4x squared add 7 minus 8x lots of 2x add 3. So that is greater than 0. Okay, now let's expand the brackets. So 2 lots of 4x squared is 8x squared. 2 lots of 7 is 14. Then we go minus 8x times 2x minus 16x squared. Minus 8x times minus 3 is minus 24x So all of that is greater than 0. Now we got 8x squared minus 16x squared. So we got minus 8x squared. And we got minus 24x. Add 14 is greater than 0. We got a common factor of 2. Divide that away, we get minus 4x squared minus 12x add 7 is greater than 0. Now we need to do one more thing, that's multiply through by minus 1. So that makes everything negative positive and vice versa, and it flips direction of the inequality sign. So finally we get 4x squared add 12x minus 7 is less than 0, as we wanted it to be. Okay, and then part B wants us to find the values of x for which y is increasing. So, in other words, we want to solve this quadratic inequality. So we want to solve 4x squared add 12x minus 7 is less than or equal to 0. So to do this, let's think of it as an equation. So 4x squared add 12x minus 7 is equal to 0. Now we're going to solve this, which is going to find us where the quadratic graph cuts the x-axis. So then we're going to be able to find our region from that. So it's only 2 marks, so we should be able to factorise this guy. Not many things multiply to give us 7, it's just 1 and 7. So we can plug those in. Now we do know that 1 is going to have to be positive and 1 negative. Now to get the 4x squared, we could either have a 4x and an x, or we might have a 2x and a 2x. Now while I was saying that, I realised we're going to need a 2x there, and then we're going to need a 2x over here as well. Now we need to get plus 12x in the middle. So if we have 2x plus 7, then that 7 multiplies the 2x in the other bracket to get us 14x. And then we want minus 1 in there, so then minus 1 times 2x gives us minus 2x, and we get positive 12x as we want to. So, if that is equal to 0, then we get 2x minus 1 is equal to 0, so x is equal to 1/2, or if 2x plus 7 is equal to 0, then x is minus 7 over 2. So the quadratic graph is going to look awesome drawing as always. So it's going to look something like that, where this point over here is minus 7/2, and this point over here is 1/2. Now the region that we want is, well, remember we are trying to solve 4x squared plus 12x minus 7 is less than 0. So we want the x values that generate the bottom part of the graph. So we want then x values strictly greater than minus 7/2 and strictly less than positive 1/2. They have to be strict inequalities. If they were equal, if x was equal to these values, then the gradient function dy by dx would equal 0. It wouldn't be less than 0. So that's our solution. That's that question done.